What an exciting event it has been, with many experts sharing their experiences on deploying open source platforms in chip design and verification. Spreading across RTL design, FPGA power, performance and area analysis to system Verilog constraints, UVMLint, we have had a full course meal served in a platter. With AI coming in a big way into chip design, we also heard how open source tools can help with your AI strategy. We will now have a live Quanda accumulated over all sessions. Anusha from VerifWorks will moderate the Quanda session, with experts including Srini, Narahari and others doing their best to answer. If there are further open questions, contact us at AsFigo. You can visit our website at www.asfigo.com.
Thank you, Shanvi, for that powerful session. It's been a perfect way to conclude our talks today. And with that, we have come to the end of our speaker sessions. A big thank you to all of our incredible speakers for sharing their knowledge and expertise with us today. I'm sure everyone here has gained valuable insights that will help us move forward in semiconductor industry. So before we wrap up, I would like to discuss the questions which we all are posted. The first question by Naresh Neelakantan have posted, could you give some examples of real-world usage of IEEE 1075, 1076 standards in linting and how it impacted the project?
Thank you. I think we kind of answered it on the text. I'm going to admit, this is Srini, by the way. I have not used these standards, so we would certainly be open to see what we can. But as far as I know, these standards, again, I have never even opened the standard, so shouldn't be talking. But the idea of linting is certainly applicable to a lot of languages. And if you have an open source parser available for this, there is really no reason in today's world that we cannot write something on top. So just for most of you who are tuning in, you probably were thinking system Verilog is so complex that we cannot build our own stuff on top, right? That's for the specialized EDA companies, which is the Siemens, the Cadence, the Mentor, the Synopsys, and etc. And I used to work for some of them, right? So in full disclosure in the past. So point is, with the last 2-3 years, with Google spending a lot of effort in building an open source parser, it's called Variable, and also the Slang and PySlang, and there are a few others available. It's really possible that your language that you're looking at has a parser, in which case, yes, the answer is yes. But honestly, I have not spent time, so I'm going to move on.
Yeah, thank you. Thank you, Srinivasan. And another from Naresh Neelakantan only. The question is, do you have some performance parameters like time saved or performance of coverage to Nambi?
Nambi, in case you're still there and if you want to take up, please take over. In case in my site, I do have a data point. I don't know if Nambi is there, but okay. So for some of you who are onto the LinkedIn, please go and look for this gentleman named Abidan Efodi. He is in Israel. He used to work for Apple. And then just one sample of probably it's in one of the slides on the operator precedence. If you look at it, he's about 15 years experience. You all know what Israelis can do. The whole world knows. And he's one of the brightest engineer that I have seen. 15 plus, he's senior guy. And he spent at least 2 hours debugging a very, very small issue. When I say small, of course, the impact is big. Now, it's a kind of an afterthought. After he did it, he didn't stop. And this is the idea of open source, right? You don't stop at your challenges. He very kindly, without being asked, I think he extracted a small test and then put it on LinkedIn saying, hey, give me back 2 hours of my debug time. Of course, technically what you have done is right, but I wasted 2 hours. And imagine a 15-year experience Israel person is spending 2 hours. I would imagine I would probably spend 3-4 hours debugging it. Somebody could be spending 2 days also. I'm not, doubting anybody's. It all depends on whether you had your coffee or tea or, whatever you do to boot you up and then debug it. So that's the kind of live performance numbers we are talking about. 2 hours of debug time is something big. And the good news is within next 2-3 hours, we were able to add that as a rule. And today it's available on the PySlint platform. And of course, if we are not restricted to a platform, we could port the same things on any other parcel that you have. For example, it could be variable, it could be Ruby based, could be Rust based, or it could even be a closed platform such as Wordy. So in Synopsys has a Wordy and it has an NPI. There's really no reason we cannot take this rule and implement it as a closed source, right? So that's the kind of, I'm just giving you one sample of what performance you can take. But if you look at this is on the constraints at Nambi, in case you want to add anything. It's not there. Okay, I'm sorry, I'm not looking at that in this. But then there are also assertions. For example, we haven't shown it today, but there is an SVALint that Ajita is leading. And it's also open source right now in terms of the specifications. So please go and look up AsFigo and then /SVALint. Should be able to find it. And that SVALint has several interesting performance checks for your assertions, such as if you have too many threads going on your antecedent, and some of you probably correlate back to this assertion history of us, me, Ajita, Ben Cohen. We have written books in PSL, SVA, multiple versions, including Indian edition. And some of you have shown interest. Thank you. I think Rama will take care of that part. But back to it, yes, there are several assertion rules that we can implement to save performance or to flag potential performance issues in your assertions. So do we have all quantification done? The answer is no. And again, the mileage will vary for sure. And we want you to build your own rules and then run with it. Ideally, come back and present to us. Otherwise, in one of the future versions, probably we'll have one in Europe, one in US. That time, I would openly welcome you to share your experience. Thank you.
Yeah. Going to other question from Rama Monica Kaudamachili. Does UVMLint tool look for existing UVM error or fatal prints, or does it suggest where to add them?
It's a very interesting question. This UVMLint is not a code generator, right? Please understand. What it does is it is kind of a helper to review your code. It says, hey, you have done this. Is this okay? Not okay. That's all it's going to do. It's not going to write code for you. That is a different technology we are working on. Ajita will be talking in about, I think, a week from now in London. It's called State of OpenCon. That recording should be available soon. After that, it's conducted by Open UK as an initiative. Again, we have some online registration if you want to take a look. We're going to talk about what you're asking here in terms of generating code. If you're using Amazon Q Developer or GitHub Copilot, we do show how the same technology that we are showing here is actually capable of handling your Gen AI assistant to do exactly what Rama just asked for. But just to be fair, UVMLint can do it for you. But the idea of UVMLint is to review your code than to generate code for you. Yeah? It can suggest potentially yes, but it's not going to generate code for you at this stage. And if there is a misunderstanding of the question, please do clarify. We'll be happy. And you can come live as well if you want to talk. We'll be happy to take up. Thank you.
Yeah. Other from Mrinal Kanti Debnath. The question is, can you please show how to integrate Verilator and PySlint with VS Code?
Excellent question.
Q&A.
So, and this is later to the previous one. We have already seen extensions of VS Code with this integrated with Amazon Q and GitHub Copilot. There is really no reason we cannot do that with Verilator on PySlint. Just that we have not spent time. It could be a good intern project for any of those academic institutions. Tyagaraja College from Madurai, it's one of my alumni. So I saw somebody registering, assuming they are listening, or anybody in Bangalore, BMS or RV or any college for that matter. If you're tuning in and then you want to work on this, drop us a note. We'll be happy to work with you. But please make sure it's open source, because PySlint is open source, Verilator is. VS Code is free at least, and then we should be able to do it together. I'm not saying it's done. There's no reason why we cannot do this. Thank you.
Yes. And from Vijay Kumar, there's a question. Thanks for the session. Based on AI, ML like using VC_SP glass, we can do it. May I know like what types of security lintings are done? Can you give some examples?
Hi. Thanks for the question. So in my slide, I just give an example of a constant, right? Numerical constant that is used. So that can be exploited by side channel attacks. In fact, PySlint can actually flag magic numbers, unexplained numerical constants. So, and it may not directly tell it's a security lint issue or something like that, but it asks you to probe those areas and probably rewrite, right, in the example that I showed, especially from a security lint aspect. Hopefully that answers the question.
And if I may add, we have built something. I don't think we have put it on the open source yet because safety is a different problem altogether. So security. So it's called Safety Lint. So for those who are interested, there is a standard called MITRE, and that defines actually RTL coding guidelines for automotive grade RTL designs. And if you're looking at those there are CW123 or whatever, 340 and etc. Those are the checks that we have implemented on top of PySlint for a specific customer use case. So technically, yes, I agree with Narahari that one rule is certainly doable, and there are few more identified by MITRE. It's called CWE, I think. It's called Common Weakness Enumeration. If you Google CWE and MITRE, you'll find it. There are rules available, and yes, we can build it. Thank you.
Yes, another query got in the session regarding hardware attack. I have read a paper which identifies malicious code by using PyVerilog package. It uses lint plus graph visualize tool to visualize the RTL structure, and it will be used to capture the unused or malicious code.
That's more of a comment, I think.
Comment, yeah.
It's a comment. Yeah.
It's one of our ex-employees, Jayaraman. Thank you.
Yeah.
I know he has built on top of PySlint several things. In case he's tuned in, he can also talk about it, Jayaraman. You can also advertise yourself if you want. Give your GitHub link. You built your own tool to generate UVM code or something, and then based on our lint technology, yes, feel free to talk about it. Yeah, thank you.
Yes. And from Naresh Neelakantan, we have got shift left is the current and next trend. Very good mention. More quantification on saving time, money, or effort might be highly appreciable.
Comment noted.
Yes, comment.
It's like a comment.
And of course, next, hopefully, Naresh, you can come and talk about it in our next session on the same thing. Thank you. Please do.
Yes. The last one on cybersecurity and side channel attack is also trending. Is anyone covering AI or DL as well? From Naresh.
I think the Keshav speaker covered ML aspects of it.
Yeah, he did. And somebody commented also.
Good. Very good. Yeah. Yeah. Okay.
From Bhuvanesh G, there's a question. As a beginner, what are all the projects that an individual need to focus on to get hands-on experience with FPGA?
Okay.
Regarding this,
If any of you, I don't know. I mean, there are many possible answers, but
That is.
Can I?
Yeah.
Hi, this is Harshvardhan. For FPGA development, what you can really start with is having one of the, like some kind of a small design, and just think through with the design aspects. Like, let's say that you are building some kind of a project like a digital watch. So it is a very small design, right? It has a counter, it has a clock, and it has some loading value, load parameters. So these kind of, thinking through the design that you develop, it would start your process very smoothly. And later you can refer some of the books where, which are good in RTL, concepts. And also on the basics of Verilog or system Verilog. You can just start with all the syntax and stuff like that. And also there are you can start with some of the tools from Xilinx or Altera that are student version or free versions are available. That will make your learning smoothly. So you can just start with that. Yeah. So yeah. Thank you.
If there are further questions, I'm sure we can do it offline too, but yeah, we'll kind of cover a few more questions and then we are almost running out of time, but yeah, please.
Yes, from another from Naresh only. Do we have an open source tool chain on the web anywhere?
For specifically for our domain, yes, quite a bit. Please look at all this validator, PySlint, variable, etc., etc. But for your own design, now linking back to your previous question, the first question on 75, IEEE 1075, I'm not sure.
And another, the last final one, any minimum requirement specification for the test benches, gates, MEM, etc.
Do we have minimum requirement specification for the test benches? Not sure what the question really is, but I don't think I understand the question. Sorry. Naresh, I believe you're there. If you want to please talk about it, expand the question, we'll be happy to talk about it. If not, we can go to the next one. Let's do last. Oh, this one. It's all done.
I think all our questions will, all questions have been done.
Any other question live? Please talk. We have a minute or two more if you want. Otherwise, we will. Thank you, everyone. Thank you.
Yeah. So you can
Yeah, and with that, we have come to the end of our Q&A. Before I finish, I encourage you all for taking advantage of the networking opportunities available. So, well, thank you again for all your participation, and I hope you enjoy the rest of the conference. All right. Have a great day. Thank you all.
Okay.